We're going to take a look at triangle inequalities here. Okay, so we've talked about the relationships with angles in certain kinds of triangles, like isosceles triangles and equilateral triangles. So isosceles triangles, we know that the base angles are always congruent. Okay, and then in equilateral triangles, we know that they're also equiangular, meaning all the angles are congruent. So we know that those all have 60, 60, 60 degree angles. But what if we have a triangle like we've got right here that has unequal sides? It's not isosceles and it's not equilateral. Is there anything special about this? Well, yes, there is. So we have something called the unequal sides theorem. So if you know that your triangle is scalene, like this, there is something special about the sides and the angles, and this is what the unequal sides theorem says. It says if two sides of a triangle are not congruent, then the angle opposite the longer side is the larger angle. So looking over here, we've got side length of 6 and side length of 8. Clearly, 8 is the larger side. Okay, so it's saying that the angle opposite that longer side, which would be this angle here, is the larger angle of the two. So angle A is larger than angle C. We could write that. Angle A is greater than angle C. Alright, so then if you read this here, it says one can then conclude that in any triangle, the largest angle is opposite the longest side, the middle of these three angles is opposite the middle of the three sides, and the smallest angle is opposite the shortest side. So looking at a little example down here, it says list the angles from smallest to largest. So to list these in the correct order, starting with the smallest, look at the smallest side, which is obviously AB of length 6. So that means the smallest angle is always going to be the one opposite the smallest side, which opposite would be this guy, angle C. So we would start with angle C if we're listing it, and then we say, okay, 6, 8, 9, 8 obviously comes next, so the next angle would be opposite of side BC, which would be right here, angle A. And then our third one, of course, would be opposite the longest side, which is 9, so angle B. Let's go ahead and look at our next theorem here. Similar to this one, unequal sides theorem. So make note here, with the unequal sides theorem, they give you the side lengths and then you list the angles yourself. So for the unequal angles theorem, it's going to be kind of the opposite. Let's see if I can zoom in. Alright. So for the unequal angles theorem, they're going to give you the angles and you have to do something with the sides from there. Okay, so let's read this. It says, if two angles of a triangle are not congruent, then the side opposite the larger angle is the longer side. So basically it's the same theorem, just in reverse. So if we are given two angles here that are not congruent, then they're saying that the side opposite the larger angle is the longer side. So obviously 62 is the larger of the two angles. Therefore, if you look at the side opposite 62, so BC, that is going to be longer than side AB, for instance. So, and then it says, notice that this is the converse of the unequal sides theorem. Basically says it in reverse. So let's look at an example. It says list the sides from smallest to largest. Okay, so first we would want to find the measure of the third angle here, which we can do if we do 88 plus 34 and then do 180 minus that. And we would get, for our remaining angle, that would be 58 degrees. So let's find that first, 58 degrees. Okay, so now we can go ahead and label the sides. So find the smallest angle measurement. Well, that clearly is 34 degrees over here. So the side opposite that smallest angle is going to be our smallest side length, which is AB. So we would list AB first. Alright, next of the three angles would be 58 degrees. And the side opposite 58 degrees is side BC, so that is our middle length side. And then the largest angle is 88 degrees, and so the side opposite that is going to be our longest side, side AC. And then we have it ordered from smallest to largest. So again, make sure you understand the difference in the two theorems. In the unequal angles theorem, they gave us the angle measurements, and then from that we were able to order the side lengths. Alright, scrolling down here, next we come across the triangle inequality theorem. Very important theorem here. So before we jump into that, let me ask you a question. Let's say I gave you 3 sticks that I picked up out of my backyard. Could you make a triangle with any 3 sticks that I give you? Think about it. Well, I need to show you a little example here. Let's say I gave you, here's a stick, and here's another stick. You try to form a triangle, and here's another stick. Well, that was kind of messed up, but you see what I mean. Let's make that a little straighter. It's not working. Alright, so there's 3 sticks that actually do not come together, and they don't make a triangle. So we can see clearly that not any 3 sides will always make a triangle. And that leads us to this very important theorem, the triangle inequality theorem. So let's read this together. It says, the sum of any 2 side lengths of a triangle is greater than the third side length, always. Okay? For instance, if I look at my little stick thing over here, let's say this down here was length 10. That stick was 10 units long, okay, or 10 inches, whatever unit measurement. This one over here could have been like 4 units, and this one over here could have been 3. So if you notice, if you add 4 plus 3, that's 7, which is not greater than the third side. So this did not work. The triangle inequality theorem says that you have to, with the side lengths of triangles, if you add 2 of the sides together, it has to be greater than the third side in order for it to make a triangle. Okay, so that is what this theorem is telling you. Pretty basic. Let's look at an example of this. So it says, can these side lengths form a triangle? And they give you 3 side lengths of 3, 8, and 5. So use your new triangle inequality theorem to solve this. So we know that the sum of 2 of the sides always has to be greater than the third side. So let's check it out. Let's say if we did 3 plus 8, that has to be greater than 5. Well, that's obvious. That would be 11 is greater than 5, and that works. Okay, let's check if we have 8 and 5. So 8 plus 5 is our sides. That has to be greater than our third side, which would have to be greater than 3, which is obvious. That would be 13 is greater than 3, so that works. Okay, we have one other one to check, and that would be adding 3 and 5 together, which would have to be greater than our third side. So 3 plus 5. Is that greater than 8? Well, this would become 8 is greater than 8. That one does not work. 8 is not greater than 8. It is equal to 8. So since this does not work, we would say nope, these could not form a triangle. Here is another possible example we could have with this kind of problem. It says, given side lengths 3 and 7 in a triangle, what could be the range of the third side? So here they're not giving you all 3 sides and asking if it could create a triangle. It's giving you 2 of the sides saying, okay, well, what could possibly be the third side here so that we still have a triangle formed? My recommendation, and I already did it on this one, draw a picture. Just jot a little triangle down. Doesn't matter what it looks like. Doesn't have to be drawn to scale. Okay, and then go ahead and just label 2 of the sides. We know it's 3. Whoops. Let's change that to freehand. Okay, so let's go ahead and label this side 3. We've got 7 over here. If I don't know the third side, I could call it x. All right, let's use our triangle inequalities theorem to do this. So let's look at it this way first. I know if I add those 2 together, it has to be greater than x, the third side. Let's write that down. So 7 plus 3 has to be greater than x. Let's solve that. That would just say, okay, so 10 has to be greater than x. Anytime you write an inequality, I want you to write it with your variable on the left side, so you're like reading it from left to right. So switch this whole thing around, which would just become x is less than 10. Alright, so we've got part of our answer. We know x, this third side, has to be some number that's less than 10. Alright, but it also has to be greater than some number. So let's set up a couple other inequalities. We said 7 plus 3 has to be greater than our third side. Well, let's do it another way. We also know this side plus this side has to be greater than 7. Let's set that up over here. 3 plus x we know has to be greater than 7. Solving this inequality, we subtract 3 from both sides, which would be x is greater than 4. Alright, so we know x has to be less than 10, and it also has to be greater than 4. And that's probably all we need, but let's check it the other way also, see what happens here. So we know this side, 7 plus x, also has to be greater than 3. So let's set up our third one. 7 plus x is greater than 3. Solving that, we get x is greater than, subtracting 7 from both sides, gives us negative 4. Well, you're always going to end up with one that kind of doesn't make much sense. X has to be greater than negative 4. Well, that makes sense. I mean, you can't have negative numbers in there, though, so we could throw that one out. Alright, so these ones would be just fine to say as our answer. And let's write that as one single inequality. Oops. So the way we do that is we put x in the middle. We put our lowest number on the left, our biggest number on the right, basically saying x is a number between 4 and 10. So we could say x would have to be greater than 4 if I'm reading it that direction, and x is something that is less than 10. And that's what we would write for our possible range values for our final answer there. Which means x could not be 4. Let me make note of that. It has to be something greater than 4. It also could not be the number 10 because it has to be something less than 10. Alright, let's get back to our note sheet over here. We've got two more important theorems to cover. Something called the Hinge Theorem. So if you notice, these are a little bit different because now we're looking not just at one triangle, but we're looking at inequalities in two triangles. Alright, so let's read the Hinge Theorem. It says, if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger included angle. Kind of wordy. Let's look at a little example over here. So they're saying if you know for sure you have a side and a side congruent and another side congruent to another side of a triangle, and you know that these two included angles are not congruent, then they are saying that the longer third side is opposite the larger included angle, meaning this one is clearly the larger angle. So they're saying that EF would have to be larger than BC because it's opposite the larger angle. Similar to some of the other theorems we looked at. So this conclusion would tell us side EF, would be larger than side BC because it's opposite the larger angle. Okay, that didn't work out so well. That should be a C. Alright, so let's look at a more specific example down here. It says find the restrictions on Z, meaning the range values that Z could possibly be. So let's make sure this falls into the Hinge Theorem category, and it does. It's saying we've got a side and a side congruent to another side and a side over here, and we know that the included angles are not congruent. Because if they were congruent, then these whole triangles would be congruent by side angle side, just FYI. Okay, but the included angles are not congruent. So we can't say the triangles are congruent, but it does tell us that the larger side is opposite the larger angle. So specifically, that means EF over here is larger than this side over here, BC. Okay, so if I set up a little inequality, I could say 45 has to be greater than 6z minus 3. Let's write that down. 45 is greater than, this is not working with me very well, that should be a 6. 6z minus 3. Oh my goodness. This is lagging big time. Alright, if we solve that, we would have to add 3 to both sides. That would become 48 is greater than 6z. Divide both sides by 6. So we get z by itself over here. And 48 divided by 6 is 8. So we say 8 is greater than z, but remember, let's flip the inequality. So that is z has to be less than 8. Write that down. Oh, come on, come on. There we go. Z is less than 8. All right, but it also has to be greater than something. Remember, it wants the range values that Z could possibly be. So let's also look back at this, see if we can come up with another inequality. Well, this one's going to be pretty basic. I know that this whole side has to be greater than 0, right? We know that a side length has to be bigger than 0. It can't be a negative number, and it can't have a length of 0. So let's go ahead and set up another one so we can get a range value here. We know all of 6z minus 3 must be greater than 0. All right, if I solve that, let's add 3 to that side and then divide both sides by 6. We'll skip a couple steps here. If you add 3 and divide by 6, that's 3 over 6, which just reduces to 1 over 2. All right, so we say z has to be less than 8, and it also has to be greater than 1/2 in order for this to work. So combining that, remember, we put our z in the middle, we put our smallest number to the left, and our larger number to the right, and our signs typically always look like this, meaning z has to be something greater than 1/2 and also something less than 8. All right, we're on our last theorem here, and it is very similar to the one we just did. It is called the converse of the Hinge theorem. Converse meaning it's basically the same thing, just in reverse. So it says, and if we review here, let me see, get rid of the drawing tool. Okay, if I scroll up here, remember the Hinge theorem gave us two sides that are congruent to two sides of a triangle, and then it gave us an angle that was not congruent in between them. Okay, so the converse is going to do something similar. It's going to say if you have two sides of one triangle congruent to two sides of another triangle, just like the other one, but then instead of talking about the angles, it says, and the third sides are not congruent, these two sides, E, F, and BC, not congruent, then the larger included angle is opposite the longer third side. So if we're looking at this little example right here, let me click my drawing tool, then this is saying if you're saying EF is the longer side, it's longer than BC, then it says angle D is the larger angle. So in this example, we would say angle D is greater than angle A. There you go. Good enough. All right, so let's look at an actual example down here. It says find the restrictions on x, meaning find the range values that x could possibly be. So let's see if we can relate it to the converse of the Hinge theorem. All right, so we got two triangles. Can you find two sides of this triangle congruent to two sides of this triangle? Well, yes, we can. We've got a side right here congruent to a side over here, right? We don't have this 25, 24. That's not congruent, but look at the one they share in the middle. That is congruent to itself on both sides. All right, so we've got two sides congruent, and we know the third sides are not congruent. So this is exactly the converse of the Hinge theorem. So look at the smaller number. That would be 24, correct? So that means if you look at the angle opposite that, that's going to be smaller than this angle over here. So we can set up that inequality and say 4x minus 6, it's going to take me a little while to write it. I would write this on your paper at the same time. That one has to be smaller than x plus 11. X plus 11. Okay. So solving this thing, we could add 6 to both sides. Let's combine some steps. If I add 6 over there, I'd get 17. I could also subtract this x from both sides and do 4x minus x and get 3x. So let's combine a couple steps here. So we get 3x is less than, if I add the 6, I get 17. All right, then obviously I would divide both sides by 3, so I would say x has to be less than 17 over 3. We can leave it just like that. 17 over 3. All right, so I want a range of values. Remember that I've got x is less than 17 over 3. So we need to also have, well, what does x have to be greater than? So let's come up with another equation. We'll do it similar to the other one we did. Let's take this 4x minus 6. That's a degree measurement. So we know that whole thing has to be greater than 0 degrees. Can't be anything negative. So let's make that one of our inequalities. So let's say all of 4x minus 6. You go ahead and write this down too. Come on. We're almost done here. Give me a 6. There we go. 4x minus 6 has to be greater than 0 degrees. All right, so if I add 6 to that side, I would get 4x is greater than 6, and I would divide both sides by 4, just combining steps. So I would say x has to be greater than 6 divided by 4, which I'll go ahead and write that even though we could reduce that. 6 over 4. Come on. 4. Okay, so we basically have our answer here. We just need to write it as one solution. We've got x is less than 17 over 3, and x also has to be greater than 6 over 4, and we'll reduce that in the end here. So let's write our final answer. We put x in the middle. We put our smaller number on the side. It has to be greater than 6 over 4, which is the same as just 3 over 2. Give me that 2. Uh-oh. It's given up on me. Okay, 3 over 2, and x has to be less than 17 over 3, and that is our final answer. And you just learned a lot of triangle inequality theorems. Congratulations.